difference, and this is just by reordering the sequence of the bytes. I didn't change any of the values themselves, just the order in which they are stored. So this can really make a huge difference to your compression ratio. And we'll need some more background info to see how that works and how we can design such stuff. That will be in the second part of this talk. And right now, I'll just give you a broad overview what you have to do, which is grouping data by context. Things that mean similar things, affect similar values, should probably be stored together. That's the main concept. Everything that's similar in meaning is probably also similar in value. So when you have this structure of what different values mean into consideration and pack that into your data format, you can get a big improvement in terms of compression, because it makes the packer has the ability to see much more what is going on, and that these are all similar values, and compress them better. And it also increases efficiency of delta coding and other simple schemes like one-name coding, because when you have similar values all over the place, those differences get small, obviously. So you get even more compression from that, additional compression, at a very low cost. And that's pretty abstract right now. So don't worry, we'll have a lot of examples later on. And a big example now, which is the V2 modules. For those of you who don't know, V2 is the Farbrash synthesizer, or real-time synthesizer, which we use basically in all kinds of intros and even some demos since FR8. So music you do with V2 gets stored as so-called V2 modules or V2M files. And these modules have two main parts. There are patches, so-called patches, which is just terminology, which is basically just instrument definitions for the soft synth. Like, how's everything set up, how's the sound set up. And there's the actual music, which is a MIDI data stream. MIDI is a standard format for music, for those who don't know, and it's just reordered and simplified. So this patch data, the instrument data, is basically unprocessed in storage. So we won't look at that again, because basically everything you change in the user interface gets mapped directly to a byte that change in the value, and there's nothing interesting going on there. But the music data is a lot more interesting, and there's a lot of magic going on there to make it compress well. For example, this music data is stored as a list of events. An event is something that is everything that means that the synth has to do some work, like change a parameter, play a note, and stuff like that, or change the instrument. There are two types of events, which are channel events and global events. Channel events only affect this one MIDI channel they're played on, which is like note commands, volume changes, and so on. And there are global events, which are basically there because the Virus 2 is not the standard MIDI instrument like you would usually have, but also has some mastering filters and post-processing effects. So that's what gets controlled by the global events. And every event has a timestamp and some additional data that is depends on what type this event is. And these channel events are grouped by their type, and each of these groups is stored separately. There are notes, a set, both actual notes and note off commands, so just play a C5 and that kind of thing. There are so-called program changes, which just change the instrument currently being used in a certain channel. There's pitch band, which is again just MIDI terminology. It's just a value you can use in your sound to change the way something sounds. This is up to the musician to use this or not, but this is a different stream. There are controller changes. A controller is something like velocity, loudness, modulation, and so on, all again stored separately, and again grouped by this type of the controller. So we've already done some reordering there because we've separated everything into global and channel events, and we have some further grouping for the channel events. The question would be how much it saves us. For the FR8 main tune in MIDI format, you have about 21 kilobytes after packing with the Crunchy compression engine. And I'll always use packed sizes from now on when I mention any specific size, because that's what's really relevant to us. We want to improve compression ratio not the size of the original data before compression. And yeah, if you use this encoding I just mentioned, so basically a prototype B2M format, you land at about 82 kilobytes, which is, yeah, not as good as we might have hoped. So the problem is that we store a lot of information. For each effect, we have a timestamp which says us where it happens. This timestamp is very big, and we store all parameters explicitly. So yeah, it's very easy to play, but it's not optimal for compression. So there's a lot of stuff we can do to make it compress better. And the first thing we'll be looking at will be timestamps. Because those timestamps are set 24-bit numbers, we could have used any other size, but yeah, 24-bit is what we picked. And yeah, as these events happen over the whole music, the time just goes bigger and bigger, because yeah, I mean, the piece of music is basically just a sequence of events, and you can easily order that. So you don't actually have to store complete timestamps. They will always increase, so you can easily delta code them, and the values will get smaller because events are close together usually. And when you do that, when you just do delta coding for the timestamps, you're down to 11 kilobytes from 88. So this is a huge improvement from what we originally had, with a minimum effect of work, with a minimum amount of work. And similarly, you can do this for the command parameters, which can be both node numbers and volume changes and so on. And most of that very smoothly or gets repeated a lot during the music, during the run of the music too. So we can delta code them as well. And if you do this on everything, you're down to 4.5 kilobytes, which, looking at the fact that we just did a few subtractions to get there, is really quite amazing. As you might remember, we started out at about 21 kilobytes. So it's really a minimum amount of work we've done so far. We've already have about a factor 4 reduction in compressed size. And from there, we can try to do some reordering. And what we did for alpha weight was reorder those event bytes as well. Because in the format I described, you have a list of events, and each of these events gets stored separately. You have the 3-byte time delta value and the 2 bytes of parameter delta values, and they just all get stored in a row. And what we do now is basically we store the first byte of each event, then the second byte of each event, third byte of each event, and so on, and then the fifth byte of each event. That's what we do. So if you would print it out as a table, what we did was basically just rotate it by 90 degrees. That's the idea behind this, is that, for example, for time deltas, most of those will have zeros in their higher order bytes, because most events are close together, so you get long runs of zeros. And usually a lot of parameters are either used or just stay the same over a long time, so again you have long runs of zeros there. That's the idea. But as it turns out, with this kind of reordering, we have about 300 bytes bigger than the original version. Well, oops. And this is the reason why you should always test this kind of transform separately. What happened here was that we did the reordering and the delta coding stuff at the same time. So we didn't even notice that this reordering stuff actually makes everything bigger. Until I started preparing the seminar, that is. So what you can see from this example both is that it's how much difference it can make to make really simple changes to the way you store your data, and it also shows how important it is to always measure if something makes a difference, how important it is, if it's worth it, and that kind of thing. And none of the transforms I will mention here or I can recommend are complex ones. It's always very simple stuff like doing differences or just reordering stuff. The more complicated stuff can